Hello, my dear students. For the reaction, rate is expressed as rate is equals to K1 into CH3 taken twice CHCl plus K2 into CH3 taken twice CHCl OH minus. The reaction proceeds. First of all, this expression, this rate expression, this expression is a sum of two distinct rate terms. First of all, you can say rate. Rate, according to first expression, the rate is depends only on alkyl halide. Rate is depends only on alkyl halide, so it follows SN1 mechanism. In the second part, the rate is depends upon alkyl halide as well as nucleophile also. Rate is depends upon alkyl halide and nucleophile, so it follows SN2 mechanism. Overall, this expression follows mixed mechanism. Based on that, third option is correct. Elimination reaction of 2-chlorobutane, meth, eth, prop, but. 2-chlorobutane converted to but-2-ene, meth, eth, prop, but-2-ene. So CH3, CH, H, CH3. In the presence of alcoholic KOH, it converted to but-2-ene. Alkyl halide is converted to alkene. That means in this process we remove hydrogen and halogen. Hydrogen, the process is dehydrohalogenation takes place. Dehydrohalogenation process takes place. In this process, we removed hydrogen atom from beta carbon. Remove hydrogen atom from beta carbon. So, beta elimination takes place. Follows Sage-Jeff's rule. Sage-Jeff's rule. Sage-Jeff's rule is also called as Zaitsev rule. Zaitsev rule. Beta elimination takes place. Major product. Remove hydrogen atom from beta carbon, which contains less number of hydrogens. So beta elimination correct, Zaitsev rule correct, dehydrohalogenation correct. This is not dehydration. Fourth option correct option. The molecular formula of second homologue in the homologous series of monocarboxylic acid. First of all, homologous series. What is homologous series? Series of elements which is differ by CH2 group. Then the series is called homologous series. Now Question is monocarboxylic acid first homologue is methanoic acid HCOOH. Second homologue is CH3COOH, ethanoic acid. CH3COOH is also written as C2H4O2. Correct answer, first option. Which of the following is correctly matched? Basic oxides, Na2O, yes, basic oxide, CaO, basic oxide, SO3, it is a acidic oxide. So first option wrong. Neutral oxides, CO2, CO2 is not neutral oxide, CO2 is a acidic oxide, so second option is also wrong. Acidic oxides, ZNO, SO2, P2O5. ZNO is a amphoteric oxide, so next option is also wrong. Amphoteric oxides, Al2O3, ZNO, SNO2. Yes, correct option, fourth option. The number of moles of hydrogen molecules required to produce 12 moles of ammonia through Haber's process. Haber's process reaction is N2 plus 3 moles of H2 gives rise to 2 moles of NH3. So 3 moles of H2 gives 2 moles of ammonia. Then for 12 moles of ammonia, how many moles of H2 is required? Cross multiply 12 into 3 by 2, 18 moles of hydrogen is required. Identify compound X according to this chemical reaction. This reaction, first of all, the reaction provided is a common qualitative test used to identify Mg2 plus ions in a solution. So Mg2 plus ions combines with ammonia and HPO4 2 minus hydrogen phosphate ions, then it gives MgNH4PO4. It is a precipitate. Which color precipitate? White crystalline precipitate. So correct option is first option. Which of the following will not give test for all the ions present in its aqueous solution? Which of the following will not give test for all the ions? Generally, complex compounds does not gives. Complex compounds does not gives. Double salts. Double salts and simple salts gives test for all the ions. Because double salts are dissociated as individual ions. Double salts are dissociated as individual ions. That's the reason double salts gives. Complex compounds does not gives. K4FeCN6 is a complex compound. That's the reason it does not gives. Which among the following reaction of alkyl halide produces isonitriles as major product? What we know, alkyl halides reacts with AgCN covalent compounds. Then it gives isocyanates. Based on that, third option. KCN gives cyanides because KCN is a ionic compound. AgCN is a covalent compound. That's the reason AgCN gives isocyanide. In which both species have the same magnetic moment is mu value same, remains same. Take the first option. FeH2O taken 6 times, 3 plus. Iron atomic number 26, argon 4s2 3d6. Remove how many electrons? Iron here Fe 3 plus form. Remove 3 electrons, then 3d5 electronic configuration. H2O. H2O is weak ligand field, so regrouping does not takes place. It contains how many unpaired electrons? 1, 2, 3, 4, 5 unpaired electrons. 5 unpaired electrons are present. You can take MnH2O taken 6 times 2 plus. Manganese atomic number 25. Electronic configuration argon 4s2 3d5. Mn2 plus form. Remove 2 electrons. This is also 3d5 and it contains 5 unpaired electrons. Number of unpaired electrons remains same. So mu value remains same. What is the mu value? Mu value is equals to 5.92 Bohr magnetons. How to calculate? Mu is equals to square root of n into n plus 2 Bohr magnetons. So first option correct. Calculate the wavelength for the third line of Balmer series of helium plus ion. Wavelength is calculated by using Rydberg's equation. The Rydberg's equation is mu bar is equals to 1 by lambda is equals to r into 1 by n1 square minus 1 by n2 square into z square. Now simplify. Which series is given? Balmer series is given. N is equals to 1, 2, 3, 4, 5. Balmer series, this is the first line. First line, otherwise this is also considered as H alpha line. This is the second line of Balmer series. Second line, or this is also considered as H beta line. Third line, this is the third line of Balmer series. Third line of Balmer series. Third line, or sometimes this is also given as H gamma line. Now question is related to third line. For third line, N1 value is equals to 2, N2 N2 value is equals to 5. Substitute 1 by lambda is equals to R into 1 by 2 whole square minus 1 by 5 whole square into Z square. Helium atomic number is 2. 2 whole square. Simplify. 1 by lambda is equals to R into 1 by 4 minus 1 by 25 into 4. LCM 100, 25 minus 4 into 4. Okay, then R 21 by 100 into 4. 4 how many times? 25 times. This is 1 by lambda value. 1 by lambda value is 21R by 25. Then lambda value is 25 by 21R. Third option, correct option. One of the commonly used reference electrodes is calomel electrode. It belongs to, we know that primary reference electrode is hydrogen electrode. Hydrogen electrode is primary reference electrode. Secondary reference electrode is calomel electrode. Calomel electrode, metal is mercury. Insoluble salt is mercurous chloride, Hg2Cl2. And anion is chloride ion, is acts as a anion. So based on this data, calomel electrode belongs to metal, insoluble salt, anion electrode. First option correct. In aqueous solution, Fe2 plus is reducing while Fe3 plus is oxidizing in nature. Wrong statement. Iron electronic configuration, argon 4s2 3d6, Fe2 plus. Fe2 plus form is 3d6. Fe3 plus form is 3d5. Fe2 plus readily loses electrons. Loss of electrons, oxidation process takes place. So Fe2 plus acts as a reducing agent, no doubt. But Fe3 plus not acts as a reducing agent. Why? Because D5 configuration is stable electronic configuration. Half-filled and fully filled subshells are relatively more stable than partially filled subshells. Correct. Assertion false. Reason true. 3 aqueous solutions of KCl are ABC with concentrations 0.2, 0.02, 0.002 molar respectively. Then want half factor. If the concentration is decreases, then want half factor value is increases. Based on that, IA less than, IB less than, IC. Among the following species, select the diamagnetic molecule. We know that total number of electrons is equals to even number. Then it is diamagnetic. Exception condition, except for 10 electrons and 16 electrons. Except 10 electrons and 16 electrons. 10 electrons and 16 electrons are even numbers, but it is paramagnetic according to molecular orbital energy diagram. B2 total number of electrons 10 electrons. O2 total number of electrons 16 electrons. NO total number of electrons 15 electrons. CO total number of electrons 14 electrons. So diamagnetic is CO. Which of the following oxide is basic in nature? Na2O is basic in nature because sodium is most electropositive metal. Most electropositive metal. Otherwise, in the previous question, I already given one table: acidic nature, basic nature, amphoteric neutral oxides. What is the product in the following reaction? Given alcohol is given MnO2. What is the role of MnO2? MnO2 is a oxidizing agent. Oxidizing agent. MnO2 is oxidizing agent. It is specifically used to oxidize allylic and benzylic alcohols. Alcohol. Yes, this is allyl carbon. OH group is attached to allyl carbon atom. So this is considered as allylic alcohol. Remove hydrogen. Why? Because it is an oxidizing agent. Then it gives CH2 double bond CH, C double bond O, CH3. First option correct. The uncertainty in momentum of an electron is 2.0 into 10 power minus 24 kg meter second inverse. Then calculate uncertainty in position. According to Heisenberg uncertainty principle, delta x is equals to h by 4 pi delta p. H by 4 pi delta p. H value is given Planck's constant 6.626 into 10 power minus 34 by 4 into pi value 3.14 into 2 into 10 power minus 24. Now simplify, you will get a 0.2636 into 10 power minus 10 meters, or it can be also written as 2.636 into 10 power minus 11 meters. Nearly equal is first option. For which reaction from the following delta S will be maximum? Change in entropy. Delta S, change in randomness, is maximum. In which case randomness is maximum? Second option. Why? In the second option, reactants are solids, but one of the product is gas. That means reactants are solids are converted to gases. Delta S value is equals to positive. Select the structure with correct numbering in the chain. First, lowest sum rule starts from right to left. First position triple bond, fourth position double bond. 1 plus 4 is equals to 5. You can start from left to right. 1, 2, 3, 4, 5. Left to right, first position double bond, fourth position triple bond. LSR value, lowest sum rule is tie. If lowest sum rule is tie, then you can check double bond is alkene, triple bond is alkyne. Follow tie break rule. Tie break rule means follow nothing but alphabetical order. Follow alphabetical order. Give least number to alkene double bond. But here what is given? That fellow given highest number to double bond. That's the reason first option wrong. Even same, second option wrong, third option wrong, correct option is fourth option. Again here also LSR value is tie, lowest sum rule is tie, then follow alphabetical order. For the reaction A gives rise to products if K is equals to 2 into 10 power minus 3 second inverse, the value of minus dA by dt when A is equals to 3 molar. Okay. So rate is equals to, rate is directly proportional to concentration of the reactants, or it can be written as rate is equals to K into A. In one more way, according to the equation, A gives rise to products, rate is equals to minus dA by dt. So based on this, left side terms are equal, then equate the right side terms. K into A is equals to minus dA by dt. What is the value of K? 2 into 10 power minus 3. Value of A is 3 is equals to minus dA by dt. So dA by dt value is 6 into 10 power minus 3. So second option correct option. Which of the following is not a state function of thermodynamic system? Which is not state function? Heat. Heat and work. Heat and work are path functions. Remaining all are state functions. Enthalpy is energy form. Internal energy is energy form. Gibbs energy is energy form. Generally, energy forms are state functions. Aluminium does not react with pure water because it covered by thin oxide layer. Nothing but aluminium is passive, passivity concept. Aluminium is passive in pure water at room temperature. Due to this protective coating. But Al2O3 aluminium oxide on its surface. The following molar conductivity Simon centimeter square mole inverse A3, luckily only one option, that is third option. E cell volts. Conductivity Simon centimeter inverse. Cell constant meter inverse. Identify the major product. First of all, here observe the point OH group attached carbon, adjacent carbon is quaternary carbon. So no doubt here methyl shift takes place. Why? Because in the presence of concentrated H2SO4, dehydration process takes place. Dehydration means remove water molecule, remove H and OH. First remove OH, OH minus form you can remove. Then here positive charge is obtained. Which carbocation? The formed carbocation is 2-degree carbocation. Adjacent carbon is quaternary carbon. So this methyl group is shifted. Methyl shift takes place. If methyl shift takes place, then here CH3, here CH3. Now positive charge is obtained here. This is 3-degree carbocation. 3-degree carbocation is more stable than 2-degree carbocation. After that you can remove hydrogen atom. Follows Sage-Jeff's rule. Sage-Jeff product. Sage-Jeff product is major product. Remove hydrogen atom from beta carbon which contains less number of hydrogens. So this is beta carbon. This is also beta carbon with respect to carbocation. Here only one hydrogen atom is present. but here 2 hydrogen atoms are present. Remove hydrogen atom from beta carbon which contains less number of hydrogens. CH3, CH3. Second option correct. Transition elements acts as catalyst because they can show variable oxidation state. And one more reason is they provide large surface area. And one more suitable reason is they have vacant d orbital. Okay. According to the given options, fourth option is correct option. Vapor pressure of a solution containing 9 grams non-volatile solute in 90 grams water is 36 torrs. On adding 1 mole water, vapor pressure increases by 3 torr. Then vapor pressure of pure water is, we know that according to Raoult's law, what we know, vapor pressure of the solution is equals to mole fraction of water into vapor pressure of pure water. Now, initial condition is given. Initial condition is given as weight of water is 90 grams, molecular weight of water is 18 gram per mole. So based on this, calculate the number of moles. Number of moles is equals to 90 by 18, that is equals to 15 moles. Now, let number of moles of solute, because solute weight only you know, solute molecular weight we don't know. Number of moles of solute is equals to small n. This is number of moles. Okay. Now substitute according to Raoult's law. P pressure 36 torrs is given. 36 is equals to number of moles of water 5 moles by total number of moles. Number of moles of solvent is 5 moles. Number of moles of solute is n into P naught. This is taken as equation 1. Now, after adding 1 mole of water, initial number of moles 90 by 18 is 5. Okay. Initial number of moles is 5 moles. Now you are adding another mole. 5 plus 1 is equals to 6 moles. New vapor pressure increases by 3 torr. Initial vapor pressure is 36. After adding 3 torrs, then total is 39. Now substitute according to Raoult's law. 39 is equals to 6 by 6 plus n into P naught. This is equation 2. Now equation 2 divides with equation 1, or equation 1 divides with equation 2, your convenient. Equation 1 divides with equation 2, that is equals to 36 by 39 is equals to 5 P naught by 5 plus n whole divides with 6 P naught by 6 plus n. You can simplify this, then n value you will get 30 by 7. After simplification, The value of n is equals to 30 by 7. Now n value substitute either equation 1 or equation 2. Substitute n value in equation 1. Then 36 is equals to 5 by 5 plus 30 by 7 into P naught. Question is vapor pressure of pure water. Simplify, then you will get P naught is equals to 66.9 torrs. Second option. Examine the compound below. How many stereoisomers having these constitutions are possible? Stereoisomers means both optical and geometrical. First of all, C double bond O. This is C double bond O does not give geometrical isomerism. This is chiral carbon atom. This is chiral carbon atom. This is also chiral carbon atom. Total number of chiral carbon atoms is equals to 3. So 2 cube 8. Total number of stereoisomers 2 power n 2 cube 8. The correct reaction profile diagram for a negative catalyst reaction. For a negative catalyst reaction, what we know, decreases the rate of reaction by increasing the activation energy. So you can check the fourth option. In the fourth option, without catalyst, this is the activation energy. If catalyst is present, then activation energy increases. Catalyst is present, activation energy increases. Decreases the rate of reaction by increasing activation energy. So this is considered as negative catalyst reaction. This is positive catalyst reaction. Rate of reaction by decreasing activation energy is called positive catalyst reaction. Identify P in the reaction. First of all, bromine haloalkane reacts with magnesium in the presence of dry ether. Then it gives Grignard reagent. Grignard reagent reacts with ammonia. Grignard reagent reacts with ammonia. Then it gives cyclopentane. Why? Because ammonia is active hydrogen containing compound. Active hydrogen containing compounds. Grignard reagent reacts with active hydrogen containing compounds. Then it gives alkane as a product. Active hydrogen containing compounds examples: H2O, ammonia, alkyne, alcohol, carboxylic acid, and so on. Which of the following have the same number of significant figures? 0.0064. Leading zeros are not significant, so 64, only 2 significant figures. Here all 4 are significant. Here 3 significant figures. Here also 3 significant figures. So second option correct option. Match the following. Benzene reacts with CO, HCl and AlCl3. The reaction name is called as Getterman-Koch. Benzonitrile reacts with HCl, SnCl2 in the presence of H3O plus. The reaction is called as Stephen reduction. Now A3B1. First option correct. Benzyl chloride. Benzyl chloride PDBSO4 quinoline. The reaction is Rosenman reduction. Toluene reacts with CrO2 Cl2 H plus. The reaction is called as Itard reaction. Ketone reacts with ethylene glycol, then it gives major product. Reaction with ethylene glycol, then remove H2O, then it gives second option. Using the same substituents, identify incorrect statements. OH is ortho para directing group, correct. CN is meta directing group, correct. Why OH is electron donating group, CN is electron withdrawing group. Halides are deactivating but ortho and para directing group, correct. SO3H is ortho and para directing group, wrong, incorrect. SO3H is acts as electron withdrawing group and it acts as meta directing group. For para-toluene sulfonyl chloride, which product is soluble in alkali during Hinsberg's test? Which product is soluble in base? If the amine is primary amine, it is soluble in base. For SO2, NO2 minus, N3 minus, identify the species in which the central atom is sp hybridized. SO2, NO2 minus, in these two cases, central atom is sp2 hybridized and the shape is bent. N3 minus, sp hybridized, geometry is linear geometry. Agide ion, N3 minus is also called as agide ion. On boiling egg white, which protein structure is destroyed first among the following, while peptide sequence remains unchanged? On boiling egg white, this is protein denaturation. Protein denaturation, so tertiary structure. The mass of ammonia in grams produced when 2.8 kg of dinitrogen quantitatively reacts with 0.8 kg of dihydrogen. So, first calculate here limiting reagent. In a chemical reaction, more than one reactant is present. Formation of product is depends upon limiting reagent. First calculate number of moles. 2800 divides with 28. 800 divides with 2. Simplify. This is 100. This is 400. Now calculate the limiting reagent. Number of moles divides with stoichiometric coefficient. 100, 133.33. So here limiting reagent is N2. Limiting reagent is N2. According to this equation, 28 grams of N2 gives 34 grams of NH3. Then question is 2800 grams of N2 gives how many grams of NH3? 2800 into 34 by 28. 3400 grams. The correct order of first ionization enthalpy is, we know that all these are the period elements. Periods left to right, atomic size decreases. Ionization energy is inversely proportional to atomic size and directly proportional to stable electronic configuration. So the correct option is Third option. Why beryllium electronic configuration is stable. 2A group elements first ionization enthalpy is more compared with 3A group elements because of stable electronic configuration. Even 5A group elements first ionization enthalpy is more compared with 6A group elements because of stable electronic configuration. The semicarbazone formed from acetone contains how many nitrogen atoms? 3 nitrogen atoms. How? Acetone CH3COCH3 plus semicarbazone NH2 NH CONH2. Remove water molecule, then CH3CH3 C double bond N NH CONH2. 3 nitrogen atoms. Along a period, the chemical reactivity of elements increases uniformly from group 1 to group 18. No, false. Increases from group 1 to group 17. That is correct statement. Group 18 chemically inert. Chemically inert. So reactivity decreases. That's the reason this is wrong option. Oxides of group 1 elements are generally basic, where oxides of many group 17 elements are acidic. Correct. Statement 1 false. Statement 2. Identify major product X. First of all, benzene reacts with COHCl, anhydrous AlCl3, CuCl. This is Getterman-Koch reaction. Getterman-Koch reaction product is benzaldehyde. Now benzaldehyde reacts with LiAlH4, reduction takes place and it gives benzyl alcohol. Among the following, which compound contained a COOH group? Sulfonic acid? No. Picric acid? No. Aspirin contains COOH group. Ascorbic acid also? No. Correct answer only C, second option. The carbohydrate unit associated with DNA is asked about through these statements. DNA, it is a pentose sugar, correct. It is present in pyranose form, wrong. It is present in furanose form. It is deconfiguration, correct. When free, it behaves as a reducing sugar, correct. It is alpha anomeric form, wrong. It is beta anomeric form. So A, C, D, first option. Identify the incorrect statement regarding group 15 elements. Dinitrogen is a diatomic gas which acts like an inert gas at room temperature. This is correct statement only. Why? Between nitrogen triple bond is present, bond energy is high. That's the reason it is chemically inert. The common oxidation state of these elements are -3, +3 and +5. Yes, this is also correct. Nitrogen has unique ability to form p-pi multiple bonds, correct. The stability of +5 oxidation state increases down the group, wrong. Why? According to inert pair effect, stability of higher oxidation state decreases down the group. Nitrogen maximum covalency is equals to 6. Wrong. Maximum covalency is just 4 only. So incorrect. D and E are incorrect. First option. Among SBF5, PCL5, BRF5, XeOF4, which species show octahedral electron pair arrangement around the central atom? Yes, BRF5 shows and XeOF4 is also shows octahedral geometry. Once check the previous video, I explained very clearly about this. Thank you.